to enable Australia to export these foods more easily. CSIRO researchers have successfully developed a modified atmosphere packaging, or MAP, for broccoli exported to Japan. After packing and sealing, the atmosphere around the produce is modified by the plastic film, which slows down the ripening process and holds in flavours. The produce can be exported simply and cheaply without waste, and fruit, vegetables or flowers can be delivered fresh after their normal season has ended.
We've been working on all sorts of technologies that can increase the storage life of food, basically horticultural products, and one of the main ones of that is the modified atmosphere packaging, and we've been quite successful in producing a number of packaging films which are being commercially developed. One of our major products has been a broccoli film for packaging large size boxes, sort of 10 kilos, and that will allow the broccoli to be stored for about 4 to 6 weeks, which is long enough for it to be sent by ship to Japan, which is one of our major areas for export. The project started about 3 or 4 years ago. ANL, the National Shipping Line, were looking for products that would help to extend the storage life of various products so that they could send them overseas. The idea of modified atmosphere packaging has been around for quite a long time, but the actual application of developing films has been quite hard. And I think this is about the first major development of a modified atmosphere bag so far in Australia. We've based the film on a commodity polymer to sort of try and keep the costs down. That's polyethylene. But we do have special additives which are put into it to affect the permeability, the rate at which the gases can cross the film. And they have to be added at the master batching stage. And then the master batched polymer is blown into the film and made into the bags. In the master batching stage, the additives are mixed in with the polymer at a high enough temperature such that the polymer melts, and the different screw formations mix it all in, but carefully so as not to degrade our additives. And then this is cooled down in the water bath and chopped up into little pellets to be used in the conventional film blowing equipment. Produce, when it's harvested, continues to breathe or respire, so it's taking in oxygen and giving off carbon dioxide, and that is basically the main way in which the product will age. Once the product is harvested, it's removed from the methods of reproducing extra starch and photosynthesis. So it's got its own store, and the respiration keeps using that up, and that's what ages the product and why it eventually is dead and you have to throw it out. So the main way of extending shelf life of produce is to slow down the respiration rate, and the best way to do that is to reduce the temperature, which is why you put it in the fridge. And on top of that, you can also slow down the respiration rate by changing the atmosphere around the produce, and you lower the oxygen and raise the carbon dioxide. So if you can find the right atmosphere, then you can store it for, as I said, 4 to 6 weeks. And the plastic film helps to produce that atmosphere, because once you seal something up in a plastic bag, and if it's still breathing, it's going to lower the oxygen, and as it breathes out the carbon dioxide, then that builds up inside the plastic bag. And our job was to develop a plastic film that had the right permeability, would let in the oxygen and let out the carbon dioxide at the right rate to build up the optimum atmosphere. So to some extent we have to develop a film for each separate fruit and vegetable. ANL have developed a protocol for the handling of the broccoli between harvest and packing, and that involves washing with chlorinated water to sort of remove all the dirt and bugs, and also At the moment, it's suggested that the packaging doesn't happen straight after harvest and cooling, that the broccoli is left for about 2 days, because the respiration rate tends to skyrocket when the broccoli is harvested, and we feel it's better for the respiration rate to stabilise after cooling before you actually put it in the bags and seal them up. So once the broccoli's been packaged and the bag's been sealed, the most important aspect is then to keep the temperature at the optimum value, which is about sort of 0 to 1 degrees for broccoli, and so that it needs to be in a refrigerated container for sea freight. Prior to this film being developed, broccoli that was being sent for a long distance was usually just packaged either in a plain plastic bag which wasn't sealed, and it also often had top ice to keep it cold, and that really is detrimental to the condition of the broccoli, because you get water sitting on top of it, and sometimes sort of freezer burn from the ice, and if it melts then you have the condition for possibly growing bacteria and things like that. So the bags definitely keep the broccoli in better condition than top icing. When we test the bags in laboratory conditions, after the sort of, say, 4-week low temperature storage, we take the broccoli out of the bags and simulate a marketing stage, which involves, say, 21 degrees for a number of days, and it's quite obvious that the broccoli that's been stored in a modified atmosphere stays green and fresh for a lot longer than broccoli that's just been in air for the same length of time. We see the modified atmosphere packaging and the other technologies that we're working on in the food industry as having great potential to affect Australia's export markets and opportunities. With the Asian market growing as it becomes more developed, there is a lot of opportunity for export of Australian food products to Asia that will require some sort of packaging to help it with the extended shelf life.
Modified atmosphere packaging is semi-permeable to maintain the best atmosphere around the product. While it allows the product to respire, it actually slows down the rate of respiration. The packaging does this by controlling the level of oxygen and carbon dioxide and absorbing ethylene, the main gas responsible for the aging of the product. As a result, product quality is maintained and shelf life is extended.